Um, a very good evening to all of you. This is Dr. Aisha, postgraduate resident in microbiology. I have applied for oral presentation, and my topic is molecular characterization of resistance genes in multi-drug resistant gram-negative escape pathogens. In this, I will be focusing on the genes which produces ESBL. ESBLs are the class ESBLs belongs to class A of Ambler's classification. The genes which I have detected are TEM, that is Timora, SHV, CTXM1, and CTXM2. The organisms which produces ESBL um, are the enzymes. These enzymes are resistant to all categories of penicillins, first generation and the second generation cephalosporins, and the extended spectrum cephalosporin, that is the third generation cephalosporin, and monobactams. But they will be sensitive to cephamycins and carbapinins. And these can be inhibited by beta lactamase inhibitors such as clavulanic acid, etc. Okay. Coming to the multi-drug resistance thing, this is multi-drug resistance is the multi-drug resistant organisms are the organisms that are resistant to more than one antimicrobial agent in more than or equal to 3 antimicrobial categories. Okay, escape this escape is an acronym which stands for Enterococcus faecium, Staphylococcus aureus, Klebsiella pneumoniae, Acinetobacter baumannii, Pseudomonas aeruginosa, and Enterobacter species. These organisms has been put at one category because these all have the same, more or less same kind of capacity. That is, these organisms have the capacity of escaping to the biocidal agent of antibiotic. Because of this, their ability to develop resistance in them and get transferred to other strains of these bacteria, they are becoming more life-threatening worldwide. The resistance is mainly due to the natural selection of these resistant strains, and also due to the horizontal transfer of these genes from them to the other strains. They are becoming life-threatening and more common worldwide. Okay. The most prevalent ESBL resistance genes in gram-negative escape pathogens are the following. That is, this TEM, SHV, CTXM1 and 2 are the genes which are present, which are common to all these escape pathogens. Okay, these are the genes. So the aim of my study is to characterize these genes among the multi-drug resistant gram-negative escape pathogens, and my objective is to study their antimicrobial susceptibility pattern, to detect the production of various ESBL genes in them, and to correlate between the phenotypic and genotypic expression of antimicrobial resistance in these pathogens, in these 4 pathogens. The material the materials are the same, the multi-drug resistant isolates, these 4 isolates, which I have been obtained from various clinical samples from our hospital ICU patients. The sample size is 80, in which Klebsiella pneumoniae is 37, Acinetobacter is 18, 16 Pseudomonas aeruginosa, and 9 isolates of Enterobacter I have taken. Only these 4 organisms I have included, and have excluded the other 2 organisms because they are gram positive. I have considered only the gram negative escape pathogens. The gram positive, the Enterococcus faecium and Staphylococcus aureus is excluded, and rest all other gram negative have been also excluded. And this is a prospective analytical study conducted for 2 years from December 2019 to 21. I have tested them for antimicrobial susceptibility by Kirby-Boyer method and also by Vitek 2 compact system. I have correlated by both the methods. All these isolates are tested then for the production of ESBL by double disc diffusion method for confirmation. Then I have categorized them based on their genotype, and it has been done by multiplex conventional PCR using these primers TEM, SHV, CTXM1 and 2. This is the resistance pattern of these isolate. The Klebsiella pneumoniae, among the all the 17 out of 37, 17 were resistant to amoxicillin clavulanate. So this is the whole resistant pattern of them. This is the resistant pattern of Acinetobacter, Pseudomonas aeruginosa, Enterobacter. For the detection of ESBL screening, I have screened all the isolate by modified disc diffusion method. Then after that, all those isolate which I have found resistant to third generation cephalosporin, which is the extended spectrum cephalosporin, are subjected to combination disc diffusion technique for confirmation of ESBL production. This is the picture in which we can see in the combination disc there is a greater than 5 mm diameter than the single disc. A difference, therefore, I have confirmed that it is a ESBL producer. The controls which I have used is E. coli ATCC 25922 and Klebsiella pneumoniae ATCC 700603. Then I have all these isolates are also tested for genotype the multiplex PCR. For running PCR, the first step is what I have done is I have extracted the DNA by boiling method. In the boiling method means first I have taken an Eppendorf tube in which I have emulsified single colony of the isolate in 100 microliter of distilled water. Then I have subjected it to heating in a water bath at 95 degrees Celsius for 10 to 15 minutes. Approximately I have done for 15 minutes. Then this has lysed the bacterium. Then I have followed it with centrifugation at 11,000 RPM for 10 minutes. And then the centrifuged, I have taken the supernatant part because the supernatant part will contain the DNA. So in another sterile Eppendorf tube, I have taken that supernatant with the help of a pipette. Then this DNA has been kept under minus 20 degrees Celsius until I have run the PCR. For PCR, I have taken the 4 primers, TEM, SHV, CTXM1 and 2 at a time because I have running in a multiplex PCR machine. The parameters for running PCR were initial denaturation was done at 94 degrees Celsius for 10 minutes, then 94 degrees Celsius for 40 seconds. Then annealing was done at 60 degrees Celsius for 40 seconds. Then extension at 72 degrees Celsius for 7 minutes I have done for 30 cycles. So approximately more than 2 hours it has taken for my single PCR. This is the PCR result which I have got. In this we can see, we can compare it with the ladder. CTXM2 gene has been detected here because it is at 480 base pairs. So, and this is the entire result. I have found in most of the isolates, I have found CTXM2 gene. And in most of the Klebsiella isolates, I have found TEM gene. And I didn't found SHV in any of my isolates, and CTXM2 has been found in only Klebsiella and Acinetobacter. Therefore, I conclude that CTXM2 gene is the most common gene present in our hospital. Present in our hospital isolates samples, and in TEM is the most common gene found in Klebsiella pneumoniae isolates. And the genotypic detection I have found that genotypic detection is more reliable than phenotypic methods, because in my study, 34% of the Klebsiella pneumoniae isolates and 15% of Enterobacter isolates were found susceptible to third generation cephalosporins phenotypically. Although when I have done the multiplex PCR, those resistant genes were present. Those resistant genes were present, but they have not been expressed phenotypically yet till now. They might show the resistance in the future. So this susceptibility indicate that these genes that didn't get expressed till now will get expressed in the future. Therefore, genotyping helps in early detection of the resistance towards antimicrobials by these bacteria, and it helps in early and appropriate selection of the antibiotics by the treating physician for better outcome of the patient. And it will help in therefore it helps in our major thing that we want to save the antibiotics, no? So by knowing the genes which are showing the resistance, we can give the other antibiotic to the patient, so that we will save the these strains from getting from becoming resistance to the particular antibiotics which we are giving now. Thank you.